Here we go. Ready? All right, so number one, we want to graph, we want to find domain, range, and we want to find the asymptote. Make sure when you write your asymptote that you write it as an equation. It needs to be in the form y equals. For your domain and range, remember I'm not going to be picky with how you write those, so if you want to use interval notation, that's fine. Inequalities are fine, set notation is fine, as long as it truly matches what's going on in the graph, I'm good with that. Look off to the side where it says also be able to do this with e, meaning if I had e to the x plus 3 plus 1, would you have been able to plug that in and graph it? And while this one you could probably do in your head, right? You could plug in 0, 1, and 2 in your head pretty easily. If it had e, is that really something we could do easily in our heads? No. So truly when I'm saying be able to do this with e, I'm saying know how to use your calculator, know how to find the e button. Okay? Alright. I'm still going to do this one on my calculator though. I'm going to go to y equals, oh look, it's already typed in from last hour, so perfect. 2 to the x plus 3 plus 1. Remember that if you have old software, you're going to need parentheses around x plus 3. I'm going to hit graph, and there's what it looks like. Now, I had the last person take their test, and I'm going to give those back from the last unit. One of the things I noticed where people lost points that kind of surprised me is that a lot of you guys drew a sketch of the graph. And what I mean by sketch is that you saw a graph like this, and you were like, oh yeah, it looks like this, Miss Fessel, and here's my graph. If you don't put points on your graph, you're not going to get full credit. I'm going to say something about accuracy, which I wrote a bunch of times on people's papers. So you need to graph, I said, 3 points is good for this. So I'm going to go second graph, and I'm going to look at some of my ordered pairs. I've got a point at -4 and positive 1.5. I've got an asymptote at 1. And again, normally my asymptote lives at the x-axis, but because of this plus 1 outside that's giving me a translation up, that means that my asymptote is also going to translate up with me. -1, 5, 3, 4, 5, and then 6, 7, 8, 9, I'm off the grid, that's okay. Okay, so there's my graph. Good? Okay, so let's talk about what we see for the domain and the range and the asymptote. Domain is what? All real numbers. So remember, if you want to write it like that, you can. In terms of interval notation, it'd be -∞ to infinity. In terms of set notation, x such that x is in the set of all real numbers. So remember this fancy looking E, basically kind of like a curvy E or a C with a little line in it, is telling me exists. So x exists in the set of real numbers. What's my range? Y is greater than 1. Again, if you want to do interval notation, 1 to infinity. Again, it never touches 1, so we'd have parentheses there. Infinity is not something we can touch as well, so we're going to put a parenthesis there. Asymptote lives at y equals 1. Again, make sure you write it as an equation. That's another thing that I marked down for on the last test, is that when you had asymptotes, if you just wrote 5 is my asymptote, I'm not okay with that, because, well, what type of asymptote is it? Horizontal or vertical? I need to see it truly as an equation. Does that make sense? Okay. I think we've reached the end of what I can write on this sheet, so I'm going to switch over to some lovely blank paper instead. Let's look at the next one. I'm just going to do it on a separate sheet of paper. I'm investing $3,000 in a bank account for 8 years, 6.2% interest compounded quarterly. Okay. So remember your equation for this one. So we have 3,000 is our initial value. Oh, you can't see that. There we go. parentheses, 1 plus. Remember that we're always growing when it comes to interest. We would put our money in the bank if it was going to decrease. We get a fraction here. The numerator is our percent, but we've got to transition it to a decimal. So what should I put in my numerator? 0.062, because we have to move the decimal 2 spots over to make it a decimal from a percent. Then, in the denominator, we put how many times it's compounded per year, which is 4. Quarterly, 4 quarters, and $1. To the t times n. So t is the amount of time, and then n is the number of times that it's compounded. Alright, so I'm ready to type it in. I'm going to show you how I like to type these problems in. It always makes me feel better when I type them in to put this fraction in a parenthesis house. I know my calculator is capable of order of operations, but it makes me nervous. So this is how I typically type them in. Close, close, to the, and I could type in 8 times 4, but I just know that it's 32. And so I have approximately $4,907.71. Good? For 2? Questions so far on anything I've said? Number 1 included. We're okay? Alright. Number 3. We've got a small town with a population of 48,000 people, and we're growing at a rate of 2% per year. How many people in the town in 6 years? Here we go. Number 3. Again, initial value, 48,000 people. 1 plus. We're growing at a rate of 2%. Now, when we're talking about populations, we're not compounding quarterly or biannually or whatever else. So remember that there's no fraction here. So this is just 1 plus your rate that you're growing by. Or if it was something decaying in value, it'd be 1 minus. And then we've got 6 years. And so let's find out approximately how many people we have. So we've got 48,000, parentheses, 1 plus, bless you, 0.02 to the 6. I get 54,056 people. Remember, I like to round up. So this is in terms of people. Okay, take a quick time out for a second. I want to talk about one other thing briefly. If this hadn't been given to me as a percent, and let's say the town's population was just increasing rapidly. Let's say it was doubling. So if I told you, instead of a 2% increase, if I told you it was doubling, what would go in your parentheses? 2. If I told you it was tripling, 3, right? So remember that if you come across something like that, where it's doubling, tripling, you would literally just put that number in a parentheses. So someone last hour said, well, how should we process that with this information? If it's doubling, you've got your 1 holding it steady, plus another 100% raising it. So basically it's growing by 200%. Does that make sense? Alright. Split. So the last one. I might be able to right there. I think we'll be able to see it. There we go. Make sure you put units of measure on these. Because obviously kilograms is different than pounds, is different than so many other things. So for this problem, we want to know the mass at time 0. So this is giving me an equation of a radioactive substance that's decaying. If I plug in 0 here, what do I end up with? 13. So 13, and it's kilograms. And my answer key's far away. It looks like 9.07 for this one, yeah? And again, kilograms. So this one I just plugged in 30. So all you're doing is plugging in for t, you're plugging in 0, and then you're plugging in 30. Questions on anything else related to this? We're good?